We're still analyzing this line here, the second line in our code example number 3. So we already talked about torch load function, and now we're talking about this data that is returned by this function. So we start by looking at the types of these variables. So the first one, sample rate, is an integer. So we've talked about integer before, but the waveform now is a torch tensor. So this is something new, and this is something related to PyTorch. So a torch tensor is a multi-dimensional matrix containing elements of a single data type. So this is also very important. We only have elements of a single data type in a torch tensor, and we're talking about a multi-dimensional matrix. So torch defines 10 tensor types with CPU and GPU variants. So we have 32-bit floating point, 64-bit floating point, 16-bit floating point type 1 and 16-bit floating point type 2, 32-bit complex, 64-bit complex, 120-bit, 28-bit complex, 8-bit integer unsigned, 8-bit integer signed, 16-bit integer signed, 32-bit integer signed, 64 integer signed, boolean, quantized 8-bit integer unsigned, quantized 8-bit integer signed, quantized 32-bit integer signed, and quantized 4-bit integer unsigned. And the torch.tensor is an alias for the default tensor type, float tensor. So if we would now try to print the D type of the waveform, we see that it's a float 32. So by default, the torch tensor is an alias for the float tensor, and the float tensor is a 32-bit floating point. So it's a torch float 32, like we see here. Now, when we are dealing with tensors, and as it's mentioned before, now we need to take care about the type. So if you are not paying attention about the type, you can run into some bugs and problems, and errors or results that are different than what you expect. So some operations, they require that you have tensors of the same type, or sometimes you need to cast and convert tensors from one type to another, or you need to make sure that a tensor is of a certain type. So up until now, we didn't really worry about types in Python, but when we're dealing with PyTorch tensors, we need to be more aware about the types. There are many ways how we can create a tensor. So we can use, for example, a list or a sequence. So here we just call torch.tensor, and we have this list here, then we have a tensor. Let's take a look about the type of this tensor. So this type is an int 64, and so as I mentioned, a tensor can be constructed by from a Python list or a sequence using the torch.tensor constructor. And we can also use, for example, to create a tensor from a NumPy array. Have in mind that torch tensor always copies data. So if you have a tensor data and you just want to change its require grad flag, you need to use requires grad or detach to avoid a copy. And if you have an NumPy array and want to avoid a copy, you need to use torch as tensor. So let's have an example here. So we have a NumPy array. It will be import NumPy SMP, and we have a NP array 4. So we have an NumPy array. Now we will have a tensor, and we'll pass this a NumPy array to the constructor. So we have this NumPy array, and we have this tensor, and now we have another tensor. It will be torch as tensor A and B array. So we had our A NumPy array, then we created two tensors using the same NumPy array. So now let's change this NumPy array and let's see what happens to our tensors. So I will do that a NumPy array. So I added 1 to this NumPy array. So this is a thing in Python. This is the equivalent of a, if we have a equals to a plus 1, this is the same as a plus equal 1. So we've changed this NumPy array, but let's see what happens to our tensors. Say tensor and print another tensor. So our NumPy array was originally 1, 2, 3, 4. We added 1 to it, so it went to 2, 3, 4, 5. Then we created a tensor, just passing this array to the constructor. That means there is a copy made here. So this a tensor hasn't changed even if we added this 1 to this NumPy array. However, the another tensor, it was 1, 2, 3, 4, but we didn't do anything directly to it. We added 1 to this NumPy array, but this another tensor is like a reference to this NumPy array, but a tensor. So the modifications that we do in this NumPy array will have an impact on this tensor here. So this is what we mean when we talk about a copy. So it's making a copy when we use this case. So we have this, and then it makes a copy of the data, but it's now a tensor. So it's not influenced by what we do here. But in this case, when we use this as tensor, then it is influenced. So let's take a look at the documentation. So convert the data into a torch tensor. If the data is already a tensor with the same d-type and device, no copy will be performed. Otherwise, a new tensor will be returned with computation graph retained if data tensor has the requires grad equals true. We will talk about requires grad later, but this is what this S tensor is doing. So converts the data into a tensor without making a copy. So let's make one more test. So now we will modify our another tensor. So we will, let's subtract 1. Let's print our another tensor, and let's print our an array, A and B array. So I will just comment this out because I don't want to change anything. So this is another thing, if you don't know, in Python we use this to comment things. So now this becomes a comment. So we had our original array 1, 2, 3, 4, our A tensor 1, 2, 3, 4, and our another tensor 1, 2, 3, 4. We add 1 to the array, so the array now is 2, 3, 4, 5, but our A tensor is 1, 2, 3, 4, so there's no change. Our another tensor is 2, 3, 4, 5. Now we subtract 1 for this another tensor, so our another tensor goes back to 1, 2, 3, 4. We didn't do anything to the NP array, but the NP array, which was 2, 3, 4, 5, also goes back to 1, 2, 3, 4. So we see that in this case here, when you use torch as tensor, these two are related, so the operations what we do here, they reflect here. So this is a very important thing that we need to pay attention when talking about tensors. Another thing we notice here is a bit different from the previous examples when we loaded audio using librosa or scipy, is that now the shape of this waveform is a two-dimension array, so a two-dimension tensor. So even though we have only 48,000 samples in this tensor, but we have this shape of 1 and 48,000. If you remember, in our librosa we only had the 48,000 comma and nothing else. So this is also important to have in mind. Two things that you should keep with you when working with tensors is the type. It's very important to pay attention on the type and the shape. So with this we finish the analysis of this line. Now we will go back to tensors later, because from now on they will appear all the time and we will make operations with these tensors. But for now, let's stay here and we keep analyzing the next lines, and there will be much more to discuss about PyTorch and tensors.